Welcome to the world of sliding bearing and tribology Chapter 2.
この講義で使われるスライドは日本語で書かれ、ビデオナレーションがついています。ナレーションは英語で、説明文書の主要部分を読み上げます。この試みは、日本で働き、外国と交流があり、英語で連絡を取る必要がある技術、販売、品質管理、カスタマーなどを担当している皆様に対し、専門用語やフレーズを英語のナレーションを聞くことで、正しく学んでいただけるように作りました。
What is tribology? It is origin of the mechanism analysis of bearings. It is an academic term based on the etymology of tribo, which means of friction in Greek, and it becomes friction studies if translated literally. This term began to be used in England in the mid-1960s and is defined two sliding surfaces that interfere with each other while doing relative motion and related problems and practical applications. Although there is little essential difference from the academic field such as conventional friction and lubrication, it is an academic discipline and technology on friction and lubrication according to economy that emphasizes the relation with economy and business management strongly.
Chapter 2 explains the types and shapes of the thrust bearings and its movement and mechanism of friction. Types of the thrust bearings. Chapter 1 explained the type, characteristics, and shape of the journal bearings. Thrust bearings also have bearings that called fixed-profile thrust bearings. Furthermore, tilting pads and thrust bearings also have special thrust bearings equipped with self-leveling mechanisms developed by Kingsbury and bearings with different pivot shapes. In Chapter 2, let's explain from these various thrust bearings. Fixed profiles thrust bearing. Ring-shaped thrust metal, which called bump face, location face, etc., that simple poured white metal babbitt on top and machined flat surface is used for light load applications. It sustains the axial movement of the axis of rotation and acts as a positioning, but it cannot be sustained heavy load due to its structure. As the load and speed increased, problems also occurred, therefore by adding oil grooves to the bearing surface and chamfer in a tapered shape, so that the wedge-shaped oil film can be easily formed and the load-carrying capacity increased. Such thrust bearings consisting of tapered surfaces and planes are called tapered land bearings. Invention and improvement of thrust bearings. In Chapter 1, we took up the invention of the wheel as the invention that brought the best technological innovation since BC, but it was understood that the wedge oil film was naturally formed in the arc shape of the journal bearing that supports the axle, and pressure is generated in the oil film. Thrust bearings must be equipped with a load that acts in the axial direction of the axis of rotation. Thrust bearings supported the shaft end on the bottom of the hole that hold the shaft end, and/or the side disc of the wheel rubbed against the frame chassis, which may have been the beginning of the thrust bearing. The beginning of thrust bearings. This illustration is a human force winch called rokuro or kagura in Japanese that was used when landing a ship by human power. Even with such a device, the bottom surface red circle where the bottom plate on the lower side and the end face of the winding shaft come into contact sustained thrust load. Cylindrical hole opened in the bottom plate is a radial bearing subjected to a journal load, and the bottom is a thrust bearing subjected to a thrust load. Origin of invention and improvement of thrust bearings. A.G.M. Michel invented the tilting pad thrust bearing and put it into practical use where a bearing for pumps. Albert Kingsbury, on the other hand, was a hydroelectric water turbine bearing. In any application, bearings that require to sustain large thrust load cannot be withstood by the simple thrust ling, thus, large rotary machines had problems. Improved thrust bearings for plain rings. 8 islands were divided by the oil groove added on the thrust surface of the flat ring. This is the origin of the improvement to segment bearings. Chamfer is added to the leading edge so that a wedge-shaped oil film is easily to form with the same theory as the journal bearing, resulting in a tapered land bearing with tapered and land. If you cut it with a line of oil grooves, it will be a segment bearing, and if you add a pivot to the backside so that it is easy to tilt, the tilting pad bearing is completed. Fixed profiles thrust bearing. Ring-shaped thrust metal, which is called location face and/or bump face, only casting white metal babbitt on the shell and machined it flatly, is used for light load applications. It sustained the axial load and acts as a positioning, but it cannot be subjected to a large load due to its structure. As the load and speed increased, problems also arise, and therefore, adding oil grooves to the bearing surface and chamfer it in a tapered shape, a wedge-shaped oil film can be easily formed and the load capacity increased accordingly. Thrust bearings composed of such tapered surfaces and planes are called tapered land bearings. Types and shapes of fixed profile thrust bearings. Stepped land. Stepped land added with oil wear to prevent side leakage is called pocket bearing. Single tapered land. Double tapered land copes with bidirectional rotation. Hydrodynamic oil film formation of thrust metal. Wedge effect. As already explained in Chapter 1, pressure is generated by oil being pushed into the gap of the wedge shape. Squeeze effect. As the distance between the bearing surface and the thrust color approaches, the oil is extruded, and the viscosity resistance of the oil pushed out generates hydraulic pressure. If the opposing two-sided surface is a complete plane and the surface roughness without friction by the atomic and molecular level is achieved impossible with current surface processing technology, the oil will slip, and hydraulic pressure should not be generated. Hydraulic pressure is produced mainly by these two effects. Tilting pad thrust bearing types and shapes. Pivot position. In Chapter 1, we have already discussed the center pivot and the offset pivot, but the characteristics of both thrust and journal bearings due to this pivot position difference are the same. Pivot shape. Line pivot line contact. Spherical pivot point contact. If the shaft misalignment is large, the spherical pivot can follow the slope in the axial direction. Special thrust metal support. For thrust bearings that are subjected to sustained large thrust load like water turbine generator, the size of the pad also increases. If you hold a large thrust pad by a pivot, the pad itself deforms and the bearing surface is convex instead of flat. A commonly used solution of support method is the spring mattress method. Spring with equal spring tension equalize the pad's surface pressure. Standardized spring support of various sizes are available by Specialist by Pioneer Motor Bearings USA. Friction mechanism and sliding bearing motion. We have learned about the main mechanism and shape of sliding bearings, but in order to understand the sliding bearings further, I will explain a little about its principle of motion. Mechanism of friction. Static friction coefficient and dynamic friction coefficient. Dry lubrication and fluid lubrication. Mechanism of friction. Let's learn two theories to understand the mechanism of friction. At first, Monton-Coulomb's law of friction is the one called Dekoboko theory in Japanese. On the other hand, The theory called the adhesion theory of friction supplements the phenomenon part which cannot be explained by the law of friction over Monton, and then the adhesion theory has become the main now. What is a Monton's law? The two surfaces relative to each other have uneven surfaces as shown in the figure, and when these two sides start their relative motion, they move while riding over the bumpy slope. The reaction force generated at that time is the frictional force. An adhesive theory. John D. Sagre 1734 first recognized the role of adhesion in friction, and advocated the adhesion theory that frictional resistance occurs when the adhesion of the contact surface is pulled off. If the unevenness of the surface is the cause of friction, if the surface is polished and smoothed, friction will be reduced. However, if it is smoothed, there is a phenomenon in which frictional resistance increases. It cannot be explained by the unevenness theory. D. Sagre believed that the force that separates polished lead PB balls from experiments bonding at the molecular and atomic level that sticks when they come into contact with each other is the cause of friction. The law of friction. 1. The larger the load, the greater the friction. 2. The frictional force does not change whether the apparent contact area is large or small. 3. The dynamic friction force does not change whether the sliding speed is fast or slow. 4. Static friction force is greater than dynamic friction force. It was confirmed by a Monton-Coulomb's law of friction. Other characteristics of friction are: 4. The harder material is smaller the friction. 5. If the materials are the same, the coefficient of friction is almost the same. These laws of friction are phenomena under dry friction conditions, and when oil, water, etc. are intervened between two sides, friction conditions become lubricated friction, and a phenomenon that can be understood from the viewpoint of fluid dynamics appears.
Static friction coefficient and dynamic friction coefficient. Moving. Sliding an object placed on an apparent plane cannot be moved without applying force. The product of the friction coefficient μ and p of the object acts in the opposite direction to the friction resistance F' and the direction in which it pulls against this sliding force F. In the F smaller than F' state, the object remains stationary and does not move, and F equals F' is maintained. If F bigger than F', the object begins to move in the direction of sliding. This torque at the beginning of movement is called the breakaway torque and is called the sliding torque of the bearing. When you start moving, you can continue the movement with a light force than at rest. This is due to the fact that the dynamic friction coefficient is less than the static friction coefficient. Dry lubrication and fluid lubrication. The state of friction described so far is an explanation based on the dry friction state. Here is the explanation of the friction state, fluid friction state of the sliding bearing. When Newtonic fluids such as water, oil, and air intervene at the interface of friction, the dry friction becomes fluid friction and the coefficient of friction decreases. Recall that when explaining Tower's theory, I explained that when I pointed oil to a gear, it turned lightly, and the frictional resistance was reduced. Dry lubrication and fluid lubrication. Comparison of coefficients of friction. Material combinations of relative faces. Mild steel and Babbitt. Static friction coefficient friction dry is 0.70, friction oil lubrication 0.08 to 0.23. Changes in fluid lubrication status. Even if it is said that it is fluid lubrication, the friction resistance value has a certain width depending on the lubrication state, as you can see by looking at the friction coefficient on the previous page. Understand the Strebek curve diagram that shows changes in lubrication conditions and friction. It can be divided into 3 lubrication states depending on the state of the oil film intervening between two sides. 1. Boundary lubrication area H, 0 contact between two sides. 2. Mixed lubrication area H, or partial contact between two sides. Fluid lubrication area H greater than or between two sides floats with oil. What is the surface finish roughness of the sliding bearing? The surface roughness of the sliding bearing is generally 1.6 s. N5. This means that the height of the highest jagged mountain is 1.6 m, and the machining accuracy in microns is required for the production of sliding bearings. Wear caused by friction. The tip of the convex and convex contact is exposed to compressive stress, causing plastic deformation depending on the compressive strength of the metal material. When the force movement that pulls off the attached two sides is applied and the adhesion surface is sheared, the particles of the torn metal may fall off. The uneven tip portions of the metals come into contact with each other, tear them off, generate small metal particles, and the metal particles are sandwiched between the two sides and scratch the surface. Wear caused by such phenomena is called abrasive wear. Thank you for your attention. We will finish the slide bearing course of Chapter 2. Please look forward to the next course. Please look at the blog page of the author's hobby.